Okay guys, so this is the fractions review video that I promised you. So let's go ahead and get started, okay? So the first thing I'm going to do is multiply fractions. So if you have something like 2/3 multiplied by 6/7, okay? Here's a basic rule. When you multiply fractions, A over B multiplied by C over D, you go straight across. So it would be A times C over B times D. So if you multiply those, you get 6 times 3 is 12, 7 times 3 is 21. But then 12 over 21 reduces, 3 goes into 12 4 times, 3 goes into 21 7 times, and that's your answer, okay? And you're done. I don't do this right here. Before I multiply, I look around to see if anything will reduce. For example, see this 2. So then I look at the 3 and the 7. Do 3 or 7, does 2 go into 3 or 7? No. But look at the 6 compared to the 3 and 7. Is there a number that goes into both 3 and 6? Yes, 3. So you can cancel as long as one's on the top and one's on the bottom. So 3 goes into 3 once, 3 goes into 6 2 times. Then multiply the 2's together. 2 times 2 is 4. On the bottom, 7 times 1 is a 7. Okay. So now if we do that same kind of rule, but this time we've got some variables with it. So I have x minus 2 over x plus 1 multiplied by 3x over x minus 2. So you guys know that this x and that negative 2 are stuck together because they're added or subtracted. Same thing here, same thing here. So if you have a multiplication, we're going to go straight across, which would give me 3x multiplied by x minus 2. You could distribute it, and then x plus 1 times x minus 2. But that is not what you're supposed to do. Before you multiply, you have to look around to see if anything cancels. You just have to get in the habit of that. So I have exactly an x minus 1 on the top and exactly x minus 2 on the top and exactly an x minus 2 on the bottom. So those cancel out and they become 1's. So then on the top, 1 times 3x is 3x, 1 times x plus 1 is x plus 1, and that's my answer. So I think it's a good idea if you multiply to look around and reduce before you multiply. It's definitely a good idea, okay? All right, so here is another one. If you had 3x minus 1 over x minus 3 multiplied by 3x minus 1 over x plus 2. So now we're multiplying, which would mean the tops get multiplied together and the bottoms get multiplied together. I just wanted to throw this one in just to express to you that those 3x minus 1's cannot cancel because they're both on the top. So, you know, really these things have parentheses around them because they're stuck together. So if they ask me to simplify it completely, then the top would be 9x to the second. You have a negative 3x and another negative 3x. That gives you a negative 6x. A negative 1 times a negative 1 is a positive 1. Multiply the bottom together. You get x to the second minus x minus 6. And that's your answer. The x's can't cancel. The 6 and or the 9's can't cancel because everything's stuck together. So there's nothing you can do to that. Okay. Now I'm going to change to adding. So if you're adding, for example, if you have 1/2 added to 1/3, in order to add fractions, you have to have a common denominator. So the common denominator here would be a 6. So you say, okay, well, what do I have to multiply by 2 to turn it into a 6? That would be a 3. So I literally just went 2 times 3 is 6. So if I multiply the bottom by 3, I also have to multiply the top by 3, so 1 times 3 is 3. So we don't really, teachers don't usually go to that extensive of a discussion. It's usually like this. What do I multiply by 2 to get? 6, 3. So 1 times 3 is 3. What do I have to multiply by 3 to get a 6? That would be 2. So 1 times 2 is 2. Add them together, 5 over 6, nothing cancels, and you're done. Okay, now just a little bit more difficult. Another addition. So 3x over x plus 2 plus 4 over x minus 3. So again, I have to get a common denominator. You guys, if you have x's that are added or subtracted to something and you're trying to get a common denominator, just squish those things together. That's literally all you do to get that common denominator. So then you look at this guy and you say, okay, he's got the x plus 2, he's missing the x minus 3. So technically, I'm multiplying the bottom by an x minus 3 to get that common denominator. Therefore, I must do the same thing to the top. So I'm going to put an x minus 3 right there. Now, some people do this, 3x times x minus 3. I don't encourage that. I'm going to tell you why in just a second. Let's move to the next one. So this guy has the x minus 3. He's missing the x plus 2. So you go 4 times x plus 2. Okay, now I don't encourage it. Here's the reason why I don't encourage it. Then people start saying, well, this x minus 3 is going to cancel with that one, that x plus 2 is going to cancel with that one, and I get like 3x plus 4 or some strange thing. And that's false. You cannot cancel like that. The reason you can't cancel like that is because the top, that's really just one term, you guys. These are added together. So I can't cancel the x minus 3's or the x plus 2's right there. So to avoid it, I just don't even write that down. I say, okay, common denominator is going to be x plus 2 times x minus 3. This guy has the x plus 2. He's missing the x minus 3. Distribute right now, and you have 3x squared minus 9x. Do the same thing again. This guy has the x minus 3. He's missing the x plus 2. So distribute the 4, and I get 4x plus 8. Add them together, and I get 3x to the second minus 5x plus 8 all over x plus 2 times x minus 3. Okay, and that is your answer. If the directions does say simplify, then that is not really simplified, and that is because you still have parentheses around the bottom. So, you know, normally on these problems you don't have to do this, but if I did multiply out the bottom, it would be x to the second minus x minus 6, and just like the last problem, nothing cancels. Okay? Alright, so here's another one. Just a little bit more complicated. So this is x plus 1 over x minus 4 added to x minus 1 over x plus 5. I need to get a common denominator. So I'm going to put parentheses around these, and I'm just going to pull them together. So that's x minus 4 times x plus 5. This guy has the x minus 4. He's missing the x plus 5. So it looks like that. Now, that's not written correctly, because the way that I've written it, only the 1 is multiplied by the x plus 5. It's the entire thing that's there. So be careful. When I multiply x plus 1 times x plus 5, I get x to the second plus 6x plus 5. Do the same thing here. This guy has the x plus 5. He's missing the x minus 4. Since this is a two-term binomial, I'm going to put parentheses right there. I know the whole thing has to be multiplied by x minus 4. So when I do that, I get x to the second minus 5x plus 4. And now I multiply the top, 2x to the second, or I simplify the top, sorry, 2x to the second plus 1x plus 9 all over. The bottom is x minus 4 times x plus 5. If they ask you to simplify, multiply the bottom out. Otherwise, you're done. Okay? All right, now this next one is kind of tricky. Subtraction and addition have the same rules, but you just have to be super careful if it's a subtraction problem. Okay? And the big thing you have to be careful about is that guy right there, distributing that negative. So the beginning is the same. X plus 3 times x plus 2, common denominator, very simple, put those together. Okay, this guy right here has the x plus 3, he's missing the x plus 2. Put parentheses around the x minus 1, multiply x minus 1 times x plus 2, and you get x to the second plus x minus 2. This guy has the x plus 2, he's missing the x plus 3. So I know I have to distribute the 2x minus 3 by the x plus 3, but this negative is there. So I'm going to go negative, and then I'm going to put the whole thing in parentheses. So I go 2x times x is 2x to the second. I get a negative 6x and a negative 3, pardon me, a plus 6x and a minus 3x. That's going to give me a plus 3x minus 9. Then I simplify that, so it's x a second plus x minus 2, minus 2x a second minus 3x plus 9. The bottom is still x plus 3 times x plus 2. Simplify the top, negative x to the second minus 2x plus 7 all over. If you wanted to multiply that out, x a second plus 5x plus 6, nothing will cancel. That's your answer. Most of the time, you guys, the bottom will just stay x plus 3 times x plus 2. Okay? Okay, I'm only going to do 4 more. So now we're going to move to division. So remember, when you do division, it's what you do. So this one is 3/4 divided by 1/2. When you divide, the first fraction stays the way it is. The division becomes a multiplication. Then you flip the second guy upside down. Some of you are flipping the first fraction upside down. It's the second fraction. Okay, now just like when we started, if you wanted to, you could go 3 times 2 is 6, 1 times 4 is 4, and that reduces to 3/2. Well, that seems really simple. Well, that's because it's easy to reduce 6/4. But what if it was something really big, like, 122 over 416? Well, that's not fun. So it's easier, in my opinion, if you reduce before you multiply. So I know 2 goes into 2 once, 2 goes into 4 2 times. The 3 is not going to reduce with anything. So on the top, 3 times 1 is a 3. On the bottom, 2 times 1 is a 2. And that's my answer. Okay, now let's start to get into some variables. So if we have x minus 7 over x plus 4 divided by x minus 7 over x plus 1. Some of you look at that and you say, I need to get a common denominator. No, you don't need to get a common denominator. That's when you're adding or subtracting. We're dividing. So you have to remember the rules. So the rule of division is to write the first fraction the way it is. Change your division to a multiplication, flip the second guy upside down. Now, the x is stuck to the negative 7, x is stuck to the 4, x is stuck to the 1, x is stuck to the negative 7. You can't cancel anything unless you have the exact same thing on the top as the bottom, and we do, x minus 7 and x minus 7. So on the top, you have an x plus 1. On the bottom, you have an x plus 4, and that's it. You know that those x's cannot cancel. The reason you can't is because you have 4 people in this situation. You guys look, person, 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 person. You can't just cancel these x's and exclude the 1 and the 4. It has to involve everyone. So there's nothing you can do to this. Okay? All right, 2 more problems. Okay. So we're going to do a complex fraction. So this is 3 over x plus 1. Plus 4 over x minus 2, main division bar, 6 over x plus 5. Okay, now some people are writing it like this as their first step. Look, 3 over x plus 1 plus 4 over x minus 2 divided by 6 over x plus 5. Don't love it, and it's wrong the way it's written, because order of operations tells you the first thing you have to do is add those together. Okay, if you did that as your first step, that's fine. I don't love it. I think it's confusing, so I would not recommend that you do that. So what I would do is I would keep that main division bar very long. The bottom is still 6 over x plus 5. Common denominator on the top, draw that line shorter than the other one. So that would be x plus 1 times x minus 2. Just pull these guys together. So now we're remembering what it was to add fractions. So this guy has the x plus 1. He's missing the x minus 2. Put the x minus 2 right there. Don't write it down as 3 times x minus 2, because then you're going to make a mistake and cancel it with that x minus 2. So just distribute it and get rid of that potential error. Write it as 3x minus 6. This guy has the x minus 2. He's missing the x plus 1. So write it right there, distribute, and I have 4x plus 4. Okay? Now, on the top, 3x plus 4x is 7x. A negative 6 and a positive 4 is a negative 2. That's over x plus 1 times x minus 2. I'm going to make that long division bar a division symbol, and it's 6 over x plus 5. I cannot cancel from here. Even if this was like a 7x minus 2, if that's a division, you can't cancel. You can never cancel with division. You have to write it as a multiplication. So this is going to be 7x minus 2 over x plus 1 times x minus 2. I'm going to keep parentheses like that. Write it as a multiplication, x plus 5 over 6. Parentheses around that, showing they're stuck together. As I look around, I do not have the exact same thing on the top anywhere as the bottom. So I'm just going to multiply these together. 7x minus 2 times x plus 5 is 7x to the second. A positive 35x and a negative 2x is a positive 33x. 5 times a negative 2 is a negative 10. When I multiply those, I have a 6 in the front, and then I have x to the second minus x minus 2. So my fully simplified answer would be 7x to the second plus 33x minus 10 over 6x to the second minus 6x minus 12. If they ask me for domain, by the way, remember you have to look at every denominator that was ever throughout the problem. So look, here, 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 here. Okay? This guy right here is a restriction, but as long as I use the guy up above, I've already done everything on that one. Same thing here. This is a restriction, but if I just use the denominators that are up above, then I get everything and that will give that a 0. So if I look basically from here on up, I know that my restrictions are x cannot be equal to a negative 1, a positive 2, and a negative 5. So that's my domain. Okay? Okay, one last question, or one last problem I want to do for you, and that would be x minus 1 over x minus 5 equals x plus 1 over x minus 2. So some of you, when you're multiplying fractions, you are cross multiplying. The only time you ever cross multiply is if you have an equal sign. So on this problem, I do not get a common denominator because I'm not adding or subtracting fractions. Okay, I don't look around to see what I can cancel because I'm not multiplying fractions. Okay, this is just an equal sign. You guys know if there's an equal sign that I'm solving and my answer is going to look like x equals something. That's the only time you're going to have x equals anything, because this was the only time we had an equal sign. Okay, cross multiply x minus 1 times x minus 2 is x to the second minus 3x plus 2. Cross multiply the other way, x to the second minus 4x minus 5. And now solve it. This x squared comes over and knocks that guy out. Negative 4x comes over and becomes a positive x, so you have x plus 2 equals negative 5. Move your x over, x equals negative 7, and you're done. Okay? All right, that only took 18 minutes. So, you know, just by taking the time to watch this video, you know, it shows that you care. It shows that you want to do well on this test. So that's half the battle. So please remember, tests are big. Proper way to study for this test is to spend an hour going through your workbook from pages 1 to page 26. Then put your workbook away and try not to touch it. Do the review, check your answers as you go. Do the extra credit, check your answers as you go. Okay, and as you get discouraged and unmotivated and you don't want to prepare for this test, you'd rather go outside and, you know, enjoy the weather, I want you to remember that once you take the test, you walk in, you take it, you nail it, you walk out, you feel amazing, and you do not have homework for the 2 days after that. So fight hard, and good luck.